Hello students. In this lesson, we want to find the equation of the tangent of the parabola. Here we are using a standard parabola. The tangent is drawn at this point P with coordinates x1 comma y1 and m is the slope of this tangent line. Now, to get the equation of this tangent, first we will try to get the equation of a line which cuts the curve at 2 points. Okay, so one of the points is P. Let's say the other point is Q here. Let the coordinates be x2, y2. Now, if a line cuts the curve in 2 points, we know it is called the secant. Okay, so let's first write the equation of this secant line. Okay, so for the secant PQ, okay, so equation is, now why are we taking the secant first? Because we know if you want a tangent, the secant becomes the tangent when this point Q almost approaches this point P. Okay, so when Q almost becomes P, it gets very close to P. It can come from either left side or right side, doesn't matter. When Q approaches P, the secant converges into a tangent, or secant becomes a tangent. Okay, so the equation of the secant line. Okay, so we have 2 points, so we can use the 2-point slope form, right? So y minus y1 is equal to, the slope will be y2 minus y1 by x2 minus x1 multiplied by x minus x1. Okay, now observe this. These 2 points are on the parabola. Okay, so because these 2 points are on the parabola, they must satisfy our equation of the parabola, right? Okay, so with this, what can we say? If I substitute the coordinates of P, I will get y1 square is equal to 4ax1. If I substitute the coordinates of Q, I will get y2 square as 4ax2. Now, here I am trying to get the slope from these two equations. So what can I do? I will subtract the first equation from the second equation. So I will end up having y2 square minus y1 square is 4a into x2 minus x1. Okay, so here if I let's say write y2 square minus y1 square as product of y2 minus y1 into and y2 plus y1, we can get, so y2 minus y1 into y2 plus y1 is 4a into x2 minus x1. Okay, so now we have the slope here, y2 minus y1 by x2 minus x1 is 4a divided by y1 plus y2. So this is the slope of the secant line. Okay, so now let's substitute this back in the equation of the secant line. Okay, so what do we have here? So y minus y1 will be 4a by y1 plus y2 into x minus x1. Okay, now here this is the equation of the secant line, right? Equation of secant PQ. Now, if I want the equation of the tangent line, all I have to do is take this y2 and then substitute y1 in its place. Okay, so we can say y2 is almost y1, right? So in that case, I will get the equation of the tangent. So what is the equation of the tangent here? Okay, so at the coordinate x1 comma y1, the equation of the tangent will be y minus y1 is equal to 4a. Now if y2 is y1, so I'll have 2y1 into x minus x1. Okay, now this can be modified further to write in a way which is easy to, let's say, readily write down the equation of the tangent at a point on the parabola. So see, I'll show you what I mean here. So what do we have here? We have 2a. So let's say I have y into y1 minus y1 square. We'll get 2ax minus 2a x1. Now also remember that y1 square is 4a x1. So let us substitute that here. Okay. So I have y1. So I'm sending this to the right hand side, y1 square as 4a x1 plus I already have 2ax minus 2a x1. Okay, so finally what do we have? Y1 is 2ax and then we are left with 2ax1. So we can write the equation of the tangent as y1 is equal to 2a into x plus x1. Okay, now here maybe let me talk about one way of immediately arriving at this equation. So if you take y square is equal to 4ax is the equation of our parabola. So we are looking at the tangent at uh, point x1 comma y1. So what are we trying to do here? Wherever you have a square, okay, so you have a y square. So you try to, let's say, write it as first y into y. Now one of the y's is replaced with the y coordinate. Okay, so this really becomes y1. Now whereas on the other side you don't have x square, you just have x. So you try to take 2x there. Okay, so this 2x can be written as x plus x and one of the x's becomes x1. So you basically have x plus x1. So that is how we can immediately write the equation of the tangent here. Okay, so you can keep this in mind. Okay, so y1 and then you have 4ax. So that out of that you are writing 2a and the 2x you have x plus x, but you are replacing one of the x's with x1. Okay, now this is one form of the equation of the tangent. Now this can be written in terms of the slope of the tangent. So how can we do that? I'm taking slope of the tangent as m. So first let us rewrite this a little bit differently. So y is 2a by y1 x plus 2a x1 by y1. So this is in the form of y is equal to mx plus c. So the coefficient of x is our slope. So we can directly say the slope of this line is 2a by y1. So we are able to write the y coordinate in terms of our parameter a and the slope of the tangent line as 2a by m. And then again, so since we are looking at the tangent at this coordinate p, which of course satisfies the parabola. So we have y1 square is 4ax1. Okay, so if I substitute y1, I have 4a square by m square is 4ax1. So from here we are getting x1 as a by m. Okay, so a by m, no, a by m square. Okay, so x1 is a by m square. So that means the coordinates of the point p x1 comma y1, if you want to write it a little differently, you could have written it as a by, let's say I'll write it here. So p can be, the coordinates can be a by m square, so that is the x coordinate, and the y coordinate is 2a by m. And the equation of the tangent, okay, so 2a by y1 is m. Now what is 2a by y1 is m, and then x1 is a by m square. So what do you get here? If you substitute, you should get a by m. So the equation of the tangent can also be written as y is equal to mx plus a by m. Okay, so you can either use the first form of the tangent or the second form of the tangent. I think in most of the problems it is convenient to use, I guess, the second form of the equation for the tangent line.